Hello everyone, I am Manjari from CSCD. In this video, I am going to say about addressing modes. Now let's see what is addressing mode. In order to fetch instruction or data from the memory, it is necessary to know the address. There are many ways in which the location of an operand specifies in an instruction called addressing modes. This is actually what addressing modes means. In order to fetch a data from the memory, it is necessary to know the address where it stores. That is represented, that is we can fetch the data or an operand by using several addressing modes here. There are nearly 10 addressing modes. The first addressing mode is immediate addressing mode. In the immediate addressing modes, the operand is explicitly specified and represent in the instruction. Means move or any other instruction hash operand comma loca. Here loca is the any address memory location, in the memory location or in the register. That means, for example, c equal to a plus b. This instruction can be executed in the assembly language at hash 6 comma a, move a to c. Here add hash 6 comma a, the 6 value and the operand in the a value is added and it stores in the a, and that a value is moved to c here. This is how it is executed in assembly language. Any operand is explicitly represented by using hash mode. That is what the immediate addressing mode immediate addressing mode is. And register direct addressing mode. The operand is the content of the register. Move R, for example, move R1 R2, where R1 equal to 10. That means the above instruction moves the content of R1 to R2. The name says register direct addressing modes. The operations are performed at register locations. That means R1, R2 and so on, Rn minus 1. On these memory locations, register locations, the operations are performed. Means the above instruction moves the R1 content, that is 10 to R2. That is what it means. Register indirect, absolute or direct, indirect addressing modes. Register indirect, the effective address is the operand is the content of the register. Register indirect, the effective address is the operand is the content of the register. Here we need to understand what is an effective address. Effective address is the address at which we get operand, and the indirect addressing node specifies by placing the parenthesis. Means the effective address is an address at which we get the operand to perform an operation. Here move parenthesis of R1 comma R2, where R1 is the 10. That means we have to get the operand at the location 10. It means R1 content is 10. So R1 content is the effective address of an operand. And absolute or direct addressing mode. The operand is the content of memory location. Move a comma b. The content of a moves to a. In these we can perform operations directly with the memory locations. Here we no need to use register addresses. Directly with the help of the memory locations we can perform any operations. Indirect addressing mode. The effective address is the operand is the content of memory location. It is somewhat similar to the register indirect, but in register indirect we are using the registers as memory locations. In indirect addressing mode we are using memory locations to perform an operations. If a equal to 10, then a is the effective address of an operand. Move parenthesis of a comma 10. The content stored in memory location a is the effective address. From that address we are fetching an operand to perform an operations. that is a indirect addressing mode, and they are a index addressing mode. In index addressing mode, effective address is calculated by adding offset value or index value to the contents of register. Means x is the offset or index value. The contents of array is added to the offset or index value, then that address is the effective address. From that address we are fetching an instruction, or we are fetching a data to perform an operation. That is, effective address is x plus contents of array, a base addressing. The effective address is the addition of contents of array and rj. That means the array location value and rj location data are added, and that becomes the effective address. And that the data or instruction at that address is needed to perform an operation. Here effective address is contents of array and contents of rj. Base index with offset. The effective address is the addition of contents of array and rj and offset values. Means here, in addition to the base addressing mode, contents of array and rj and also the offset value is added to the effective address, and that address operand is used for an operation, and that instruction is used for operation too. Other addressing modes are auto increment and auto decrement related to addressing modes. In auto increment addressing modes, the value of register incremented by 1 after fetching the operand. Means for example, syntax is parenthesis of ri plus ri value equal to 100. Then at 100th location, what is the data is present, that is fetched out first. Then 100 is incremented to 101. Then the 101th location data or instruction is fetched next. That is the increment, and so on. That process incremented until the condition fails, and auto decremented first. The ri value is decremented first. Means the syntax is parenthesis of minus parenthesis of ri. This was the syntax of auto decrement. The ri value, for example, the ri value is 100. It's decremented first before fetching the data. That means the ri value becomes 99, and that location data is fetched first, and that is decremented to further 98, 97 and so on until the condition fails. Relative addressing mode. In relative addressing modes, the effective address is calculated by adding offset value with the PC, with the contents of PC. Means the location stored in the program control. The location stored in the PC is added with the offset, and that address becomes the effective address. That address data is fetched out to perform an operation. These are the some basic addressing modes present. Hope you get some basic idea about addressing modes. Thank you.